Hello students, you are welcome to sirMATHS program. Today we are going to treat standard form as it affects grade 8, descending with a JSS2. We are treating standard form. Remember to subscribe to sirMATHS for our daily program, so that you'll be updated from day to day each week. So like I said, we are going to treat standard form as it affects grade 8, which is the same as JSS2. Standard form is in the format of A times 10 raised to power n. This A stands for a number with one digit before decimal point. I said one digit before a decimal point. What do I mean by that? We have 7.32. This is one digit before decimal point. And so this is in standard form format. But something like 3.2 is not in standard form. Why? Because we have 2 digits before a standard form. So a standard form must have one digit before decimal point. This one digit can be 1, can be 2, can be 3, can be 4, 5, 6, 7, 8, and 9. Like what you have here is 7, but it is one digit, not 1, 2. Also, this one digit must not be 0. The one digit must not be 0. You have 0.373. This is not a standard form. Why? Because the digit before the decimal point is 0. So this is supposed to be 3.73. One digit before decimal point. This is for A. And this n is an integer. The n here is an integer. It can be positive, it can be negative. But an integer can be negative, it can be positive. Now let us look at an example for this standard form. And you are asked to express the following. Express the following in standard form. Let's have number 1, 32.5. We expected to express this in standard form. This can be expressed as 3.25 times 10, which will now give us as a standard form 3.25 times 10. Somebody can say raised to power 1. But that one may not be necessary, because any figure without power is automatically raised to power 1. So this is our standard form. We can be asked to express number 2, 38795 in standard form. You can agree with me that it is 1, 2, 3, 4, 5 digits. So it's not in standard form. Standard form, as I said, must be one digit before decimal point. So this automatically becomes 3.8795 times 10 raised to power. This is there's invisible decimal point here. We have invisible decimal point at this after 5. And this invisible decimal point has moved 1, 2, 3, 4. And so we now have 3.8795 times 10 raised to power 4. This is our standard form. We may as well be asked to express, let's say number 3, 85000000 in standard form. This is 1, 2, 3, 4, 5, 6, 7, 8 digits. So it's not in standard form. The decimal point is invisible here. So to express this in standard form, we now have 8.5 times 10. How many times did the invisible decimal point that is here moved? And that is 1, 2, 3, 4, 5, 6, 7. We have the decimal point here. So this becomes 8.5 times 10 raised to power 7. We have expressed the 85 million into standard form. I hope you are following. We can be given this to express in standard form 7.6. This is just to find out if you know what standard form is talking about. If you look at this, it's already in standard form, 1 digit before decimal point. So you tell whomsoever that this is 7.6 times 10 raised to power 0. Why? Because the decimal point did not move anywhere. The movement of the decimal point is 0. So this is a standard form for 7.6. This is when the number is greater than 0. When the number is greater than 0, that is what we have. The situation we're given a number that is less than 1, number greater than 1. This is what we have done. But we may be given a number less than 1 to express in decimal form. Let's look and treat some examples to that regard. Number 1, we're giving 0.52 expressed in standard form. This is 0. Remember we said that the 1 digit before decimal point must not be 0. It can be 1, can be 2, can be 3, can be 4, 5, 6, 7, 8, 9. But it must be 1 digit. And so this becomes 5.2, 1 digit before decimal point. In the previous one, you discovered that the invisible decimal point or whatever decimal point was moving to the left. So when it moves to the left, it is positive. But in this instance, you can agree with me that it moved to the right. When it moves to the right, it becomes negative. So this is 5.2 times 10 raised to power minus 1. What did we do? This is the same thing as saying that this is 5.2, 0.52. Like I said, this is 0. It must not be decimal point. Decimal point must be 1 digit before decimal point. Number 2, when the number is less than 1. We can be asked to express 0.000789 in standard form. So this will now give us 7.89 times 10 raised to power minus 1, minus 2, minus 3, minus 4, minus 5. This is where the decimal point is now. So we now say that the standard form of 0.000789 is 7.89 times 10 raised to power minus 5. This is our standard form to that regard. We may as well be given, let's say example 3. We're given 0.03078 to express in standard form. The digit before decimal point is 0, so this is not in standard form. This will now be 3.078 times 10 raised to power what? This decimal point has moved 2 places to the right. I told you to the right is negative, while to the left is positive. So this becomes 3.078 times 10 raised to power minus 2. We have expressed this in standard form. That is when the number is less than 1. The previous one we treated is when the number is greater than 1. So this is the position. There are situations will be given in standard form and we are asked to express it in ordinary number. You are given standard form and you are asked to express this standard form in ordinary number. Let's have one or two examples to that effect. Express the following standard form in ordinary number. Let's have this as example 1. This is 1.82 times 10 raised to power 3. This is descending as 1.82 times 1000 raised to power 3. 1, 2, 3. And ordinarily, this becomes 182 times. Okay? We can put it this way for your understanding. This becomes 182 times 100 times 10. That is 1 point. Why did I do that? To show you that we still have 2 decimal places. 2 0 will take care of it, and we still have 1 remaining. And so this will now give us 1820. Remember, we have 3 zeros and we have 2 decimal places. 2 zeros will take care of the 2 decimal places, and we still have 1. That is why we have this. So the ordinary number of 1.82 times 10 raised to power 3 as a standard form has given us 1820, 1820. We can as well be given a number like 7.9508 times 10 raised to power 9. This will result to 7.9508 times 0000000. How many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So this can be written 7.9508 times 10000. That is 4. Remaining how many? 1000000. Why did I break it that way? To show you that these 4 decimal places will be settled by 1000, 4 zeros. Take care of that. And that will now give us 79508 00000. This is our result. We have expressed this standard form in ordinary form. I hope you are following. Let's look for more example to this effect, that is expressing to ordinary number. We have treated the number greater than 1. Let us look at the situation we are given a number less than 1. We expected to express 3.82 times 10 raised to power minus 6 in ordinary form. This is descending as 3.82 times 1 over 10 raised to the power 6. Remember your indices. That the indices says when the power of 10 is negative, it becomes 1 over that very number raised to the same power. This is the same thing as 3.82 times 1 over 1,000,000. And that means this will result to 3.82 over 1,000,000. What does that mean? It means that this decimal point here, we move 6 places to the left. This decimal point, after 3, we move 1, 2, 3, 4, 5, 6 to the left. And what does that mean? We have 2, it's not affected by that. We have 8, and then we have 1, 2, 3, 4, 5, 6. Then we close. So we have expressed 3.82 times 10 raised to the power minus 6 in ordinary form. However, somebody can easily know that since this is raised to the power minus 6, that the decimal point will move 6 places to the left. And so you may not go through if it is especially multiple choice question. You simply start from here and count this as 1 and use 0 to make up the 6, and then you close it by decimal point and arrive at 0. So we have expressed this number less than 1 to ordinary number, and that is what it has given us. Can we have another example to this? That is number 2. Example. What we are given, 3.2 times 10 raised to the power minus 1. Raised to the power minus 1. Like you derived from the previous example, that just means that this decimal point will move 1 place to the left. This it is negative, 1 place to the left. And that will give you, this is 1. That is 0.32. This is the ordinary number of 3.2 times 10 raised to the power minus 1 is a standard form. This is the result. Perhaps you need another example. Let's have number 3. 1.12 times 10 raised to the power minus 2. This, you can say that this is 1.12 divided by 100. You remember the previous one we treated. So this decimal point will move 1, 2 places to the left, and that will give us, we have 2, 1. This is not affected by that movement. So we start from here. This is now 1, 2. We close it by this 0.1. 0. So we have expressed 1.12 times 10 raised to the power minus 2 to the ordinary number, which has given us 0.0112. That is for expressing the given standard form in ordinary form. We can use standard form to solve addition, solve subtraction, and so on and so forth. That is applying decimal standard form in solving a number, that is the operation of numbers, addition, subtraction, and so on. Let's have an example to that. We have 3.32 times 10 raised to the power 2 plus 6.68 times 10 raised to the power 2. You can agree with me that it is the same power. And you now bring out your common factor. That is why you treated your HCF in the previous grades. You can see that 10 raised to the power 2 is common. This is the bridge. This is 1, this is 2. And so the 10 raised to the power 2 is common. You now bring out the 10 raised to the power 2 as your common factor. When you divide this by this, let's apply it. 3.32 times 10 raised to the power 2 divided by this common factor, 10 raised to the power 2, plus 6.68 times 10 raised to the power 2 divided by 10 raised to the power 2, bracket close. So we have 10 raised to the power 2 as a common factor. This 10 raised to the power 2 cancel this 10 raised to the power 2. What do we have left? We have 3.32 left. Plus the 10 raised to the power 2 cancel the 10 raised to the power 2. We now have 6.68 as a remnant. And then we solve ordinarily. 8 plus 2 will give us 10. Write 0 and carry 1. That 1 plus this very 6 is 7. And 7 plus 3 will give us 10. We write 0 and carry 1. That 1 plus 3 is 4. 4 plus 6 is 10. Times 10 raised to the power 2. What actually we have is 10 times 10 raised to the power 2. But you agree with me that this 10 is 2 digits, and so it's not a standard form. We now express this 10 in standard form. This is 1 times 10 raised to the power 1 times the original 10 raised to the power 2, which was a common factor. And then we apply our law of indices, that when we have multiplication, we add the powers, since we have the same base, 10, 10. So this will give us 1 times 10 raised to the power 1 plus 2. That is exactly 1 times 10 raised to the power 3. This is the solution for applying standard form for addition. We're applying that operation of addition on this standard form. I hope this is clear to you. The same thing is when we are having our subtraction. Our subtraction, let's have a situation where we're asked to subtract. (9.38) times 10 raised to the power 4 minus 9.89 times 10 raised to the power 3. If you look at these two, 1, 2, you will agree with me that 10 raised to the power 3 is common. This is 10 raised to the power 3, and in this 10 raised to the power 4 contains 10 raised to the power 3. So here, our common factor is 10 raised to the power 3. If we divide this by 10 raised to the power 3, we have 9.38 times 10. This 10 times this 10 raised to the power 3 give us 10 raised to the power 4 minus 9.89. The 10 raised to the power 3 has taken care of this 10 raised to the power 3. So we now have we multiply this by this, that will give us 93.8 minus 9.89. How did I get 93.8? I multiply 9.38 times 10, and that has given me 93.8. We do the ordinary subtraction. Remember that this is all times 10 raised to the power 3 as a common factor. We do the subtraction. This is 1, 2 digit, that is decimal place, and this is 1. So we now carry 1 from here, which on coming to this is 10. 10 minus 9 will give us 1. This will remain 7, and we cannot subtract 8 from 7. Therefore, carry 1 here. 17 minus 8 will give us 9. Having carried 1 from here, so this will remain 2. And we now carry 1 from this 9. 12 minus 9 will give us 3. So 8 is left times 10 raised to power 3. And remember, we expected to express our answer in standard form. It's not yet a standard form because we have 1, 2 before decimal point. So this will give us 8.39 times 10. This will give us, this times it will give us 83.91 times the 10 raised to power 3. So we have 8.39 times 10 raised to power 1 plus 3. Finally, we have as answer 8.39 times 10 raised to power 4. So this is when we are applying the operation of subtraction in our standard form. I hope this point is okay. So there are situations even in multiplication we expected to do that. So only pick out the common factor. And that must be in the 10 raised to power whatever. You bring out the common factor and then you divide whatever you are given by the common factor. What actually we did is we said 9.38 times 10 raised to power 4 divided by 10 raised to power 3. That has given us 9.38 times 10. And minus 9.89 times 10 raised to power 3 divided by 10 raised to power 3. The 10 raised to power 3 cancel the 10 raised to power 3. We have as the remnant, which is 9.89. We apply the multiplication, it gave us this, and then this subtraction gave us this, times the 10 raised to power 3. And then our answer, we now express it in standard form. That has given us what we have. So this is our standard form as it affects grade 8 and JSS2. Remember to subscribe to sirMATHS so that you will be following our update weekly to enable you know your mathematics, and that is very well. Thank you. Till next week, we meet again.